Welcome back, developers. You are tuning in for the top trending open source GitHub projects this week, part 2, and we have 10 incredible projects that redefine AI, robotics, and infrastructure. We're breaking down Agent Lightning, which turns agents into self-improving machines using structured traces for training, and the autonomous trading ecosystem of MoonDev AI agents. Plus, we cover Hoppscotch for nimble multi-protocol API testing, and SeaweedFS for scalable O1 disk seek storage. Get ready for step-by-step guides on all 10.
Welcome back to Manu AGI Tutorials. Here, we explore the exciting world of AI, latest AI tools for you, so don't forget to hit that subscribe button and the notification bell so you don't miss out on the latest AI insights. So let's start today's video.
Project number 1, Agent Lightning, empowering any agent framework to learn and improve with minimal setup. Agent Lightning stands out because it transforms AI agents from static tools into continuously improving systems without requiring heavy rewrites or complex integrations. Rather than being locked into a specific framework, it supports any agent architecture, whether you're using LangChain, Microsoft's agent framework, AutoGen, or even a custom setup built with OpenAI alone. What makes this so unique is the freedom it gives. You don't have to change your core agent logic. Agent Lightning simply attaches to the framework and starts gathering structured traces of prompts, tool calls, and rewards for you. Another defining feature is the way it turns agent behavior into data that can be trained on by capturing every step of your agent's execution, actions, decisions, context. It creates a consistent dataset that can feed into algorithms like reinforcement learning, supervised fine-tuning, or automatic prompt optimization. That means instead of manually rewriting prompts or heuristics whenever your agent fails, you can feed its experiences into a loop that makes it better over time. This trainer inside model is rare. Many agent frameworks simply provide static execution, but Agent Lightning gives you dynamic improvement at your fingertips. What also makes this project special is its minimalism and flexibility. The documentation emphasizes zero code change almost when integrating with your agent. You keep using your preferred agent setup, and Agent Lightning acts as the optimizer beneath the surface. On top of that, it offers centralized store architecture, capturing tasks, resources, and traces in a unified hub from which learning algorithms draw and update the agent's policies. Finally, the project's open source nature under the MIT license, backed by a large community 4.5K plus stars, and a research paper for deeper understanding, gives it the ecosystem credibility to be adopted in serious systems. In short, Agent Lightning is unique because it turns your agent system into a self-improving machine, works across frameworks, and lets you keep your existing workflows while adding powerful learning capabilities. Before we move to the next project, let me introduce you to Teza App, the game-changing tool that lets you write a script and generate a complete video with the touch of a button. Tired of the stress and complexity of video creation? Teza AI is here to fix that. It's quick, incredibly easy to use, and can get your entire video ready with just a few clicks. Join the thousands of creators who are already making viral content with this app. Teza is the definitive software for faceless virality. It makes it incredibly easy to write scripts and generate content for the most popular short-form niches. Once you hit the start button, you'll find powerful tools like the latest AI video models like Sora 2, Smart Cut Clips for repurposing long-form videos, Streamer Clipper and Reddit Story Maker to keep your content fresh, and more. Let's quickly try out the Sora 2 model right now. I'll click on the Sora 2 Generate tab. I'll enter my prompt right here, and then click the Generate Video button. In just a few seconds, my video is ready. Let's see. Take a look at this quality.
Hello, Glow! Meet the moisture bomb your skin's been waiting for. Rich, silky texture that melts in, giving deep hydration with clean ingredients. Everyday glow? Yes, please! Try it and feel soft, hydrated, happy. Glow.
Imagine creating dozens of videos like this every week. So what are you waiting for? Try Teza App right now and get started for free. The link is in the description. You can join thousands of creators who are already hitting massive views and subscribers by making viral faceless videos in seconds, and you don't even need a credit card to start your free trial. That's it for Teza App. Now let's jump into our next project. Project number 2, WeKnora, Deep Document Understanding and Semantic Retrieval Framework. WeKnora stands out because it doesn't simply index papers or PDFs. It deeply transforms heterogeneous documents into meaningful semantic representations, and then layers intelligent retrieval and LLM-driven reasoning on top. What really makes it unique is the way it embraces the full pipeline. It handles multiple document formats: PDFs, Word, images via OCR, extracts structured and unstructured content, builds semantic views and even knowledge graphs. From there, it introduces hybrid retrieval strategies, not just keyword search, but vector-based dense retrieval, sparse retrieval, and knowledge graph-enhanced recall. That means when you ask a question, it doesn't just fetch documents that happen to contain the words you used. It fetches content that semantically matches your intent, then uses the retrieved material to provide context-aware answers. Another standout feature is its flexibility and extensibility. Every component, parsing, embedding, retrieval, generation, is modular and decoupled. That allows you to pick and plug different embedding models, vector databases, retrieval engines, or LLMs depending on your use case or infrastructure. WeKnora also brings an enterprise-friendly dimension, on-prem or private cloud deployment, full control over data sovereignty, security mechanisms, access control, so it is not just experimental or research grade, it is built for real-world knowledge management, compliance, enterprise Q&A, legal document search, academic retrieval, technical support. In summary, what makes WeKnora unique is its focus on going beyond simple search, transforming diverse document types into unified semantic knowledge, leveraging hybrid retrieval plus reasoning to answer intent-driven queries, and doing so in a way that's configurable, enterprise-ready, and deployment-flexible. That's what gives it power, not just as a tool, but as a platform you can build serious knowledge-centric applications on. Project number 3, Moon Dev AI Agents, autonomous AI agents built for algorithmic trading. This tool stands out because it brings a fully functional ecosystem of AI-driven agents together in a way that's rarely seen in the open-source trading world. Rather than being a single algorithm or backtester, it presents a multi-agent architecture where different specialized bots handle research, sentiment, risk, execution, and even monitoring of social and market signals. It's unique in how it connects those pieces so you don't just run a strategy, you orchestrate a system of cooperating AI agents. At the core, the environment begins with a research workflow. The system uses AI to scan YouTube videos, PDFs, and training texts to extract potential trading ideas, then converts those into code and backtests across dozens of datasets. That alone is noteworthy, because the typical workflow is manually find strategy, row code, test. Here it's automating the research to code jump. Alongside that, the Swarm consensus mode uses multiple large language and domain models in parallel to vote on trading decisions, effectively bringing model diversity into live decisioning. This kind of layered consensus approach is rarely packaged in open source form. What also makes it unique is the breadth of agent types. You have agents analyzing whale transactions on crypto chains, others examining social sentiment on Twitter, yet others tracking new token listings or funding rate arbitrage. They each contribute signals, while a strategic agent orchestrates execution and a risk agent watches position size, drawdowns, and compliance thresholds. The result is a system with many moving parts collaborating, not just one model making buy-sell calls. Another highlight is that the tool is built to be modular and extensible. Users can plug in their own data sources, tweak strategies, add new agent types for entirely different markets. It doesn't lock you into one style, it lets you explore a full agent ecosystem approach to algorithmic trading. In short, what sets this project apart is its agent-based research-to-execution pipeline, its use of consensus models, and its modular architecture for wide-ranging signal types and markets. Project number 4, Hoppscotch, the lightweight flexible tool that makes API testing easier for everyone. Hoppscotch stands out because it removes so much overhead traditionally tied to API testing tools and places the focus squarely on speed, accessibility, and collaboration. Right from the start, it's built to be lightweight and fast. You don't need a heavy desktop app just to try a few endpoints. It runs in the browser, works offline, installs as a PWA, and supports desktop and CLI versions too. Because of this, developers or teams on tight timeframes or constrained environments can jump in immediately. Another part of its uniqueness is that it supports many different API types beyond just simple REST. Whether you're using WebSockets, server-sent events, MQTT, GraphQL, or even custom request methods, Hoppscotch keeps the interface clean and unified. That means teams working across microservices, IoT, or modern web backends won't feel limited, and they don't need separate tools for each protocol. Collaboration and organization are baked in too. You can create collections and folders of API requests, sync them across devices or team members, and store environments with variables. That transforms it from a solo tinkering tool into something a whole team can use together. And because it's open source under MIT, you can self-host or customize as required. The theming, workspace switching, and user experience also make Hoppscotch unique. It provides distractions-free modes, custom accents and themes, and clear UI so you spend time sending and interpreting requests instead of navigating menus. Alongside this, it supports importing, exporting collections, and even snippets of code in multiple languages, helping turn tests into reusable assets. Lastly, the fact that it is a true open ecosystem built for web, desktop, and CLI with cloud sync, offline support, and open contributions means it doesn't force you into one platform or vendor. It gives you freedom to adapt. In essence, Hoppscotch delivers the power of more complex API tools, but in a nimble, accessible, and collaborative way, ideal for individuals, teams, or anyone looking for an agile API testing solution. Project number 5, Standard OpenARM 100 Project. Accessible robotics for makers, researchers, and AI developers. The SOARM 100 project redefines what an open-source robot arm can be by blending modular hardware, 3D printable components, and community-driven flexibility to deliver something far beyond a typical kit. What makes this tool unique is its commitment to truly open access and adaptability. From the STL models to the detailed build guide, anyone can source parts, 3D print their own arm, and integrate it into their robotics workflows. What stands out first is the dual leader-follower architecture. One arm can act as a leader and another as a follower, enabling teleoperation setups or mimicry experiments, which is uncommon in many DIY arms. Another distinctive strength lies in its emphasis on customization and expandability. The project supplies not just the base arm design, but a full ecosystem of optional hardware add-ons, such as overhead camera mounts, tactile sensing grippers, and compliant finger modules, allowing users to tailor the setup to their exact use case, whether that's pick-and-place experiments, vision-guided manipulation, or teaching robotics concepts. The fact that all these extensions are documented, ready for printing, and intended for community contribution raises the project beyond a static design into a living, evolving platform. Equally noteworthy is the detailed guide to printing, assembly, and hardware sourcing. The repository walks the builder through 3D printer settings, calibration checks, compatibility gauges, and servo advice. This lower barrier approach means even hobby-level makers can succeed in constructing a functional robot arm without huge cost or specialist infrastructure. The project also embraces open-source licensing, Apache 2.0, making it suitable for tutorials, classrooms, or research use without heavy legal constraints. Finally, the project aligns well with the wider trend of AI-enabled robotics. By offering a platform that's easy to integrate with vision modules, control boards, and software frameworks, it invites experimentation with robot learning, teleoperation, simulation, and human-robot interaction. In short, the SOARM 100 becomes a springboard, not just a robot arm, and that mindset of openness, versatility, and community orientation is what truly sets it apart. Project number 6, Handy. One tool to turn your voice into text, no cloud, no vendor lock-in. Handy stands out because it brings genuine offline speech-to-text capability to the desktop in a way that values privacy, openness, and extensibility above all. What makes it unique is that rather than relying on cloud servers or proprietary services, it performs transcription entirely on your local machine, so your voice doesn't leave your computer. Instead of being a locked-down black box, every part of Handy is open source and built to be extended. You're not stuck with one workflow. You can adapt, remix, or add features. Another standout feature is its simplicity matched with power. You press a shortcut, speak into any microphone, and your words flow directly into whatever text field you're using. Word processing, chat, notes, no intermediary steps. Because it supports multiple high-quality speech recognition models, including local versions of Whisper and Parakeet, it handles a wide variety of languages and hardware setups. This flexibility is rare in truly offline tools. The cross-platform design is also worth noting. Whether you're on Windows, macOS, or Linux, Handy works, giving broad access rather than limiting to a single operating system. That means whether you're on a high-end GPU laptop or a modest CPU machine, you can tap into local transcription without depending on remote servers. The fact that the tool also emphasizes being forkable means community-driven adaptations are encouraged. This isn't a fixed product, it's a foundation. Finally, the overall philosophy behind Handy makes it special. Free to use, open to modify, private in operation, and singular in its purpose. Transcribe speech to text locally. That clarity of mission combined with the freedom of open-source architecture means this tool doesn't just get the job done, it empowers you to build on it. In short, What elevates Handy is its commitment to privacy-first transcription, genuine offline performance, multi-platform accessibility, and open architecture that invites customization, making it a rare gem in the speech-to-text world. Project number 7, Agent S, empowering machines with human-level interaction on your desktop. Agent S stands out because it doesn't merely react to commands, it actually interacts with a computer environment, like a human user, turning the machine into an extension of intelligent workflows. Instead of treating the computer as a passive execution engine, this tool treats it as an active partner, enabling complex decisions, planning, and visual manipulation of GUIs in a way that mimics human behavior. That human-computer synergy is what sets it apart. At the core, Agent S is designed for generalized computer use tasks, opening applications, clicking buttons, reading screens, combining text and visual context across platforms like Linux, Windows, and Mac. Unlike more narrow automation scripts that only perform one specific task, this framework learns from experience, adapts to different interfaces, and handles new tasks without being rewritten every time. This ability to function across environments and interpret diverse visual elements makes it especially unique. Another standout feature is how Agent S achieves zero-shot generalization across entirely new GUIs and operating systems. It delivers state-of-the-art results on benchmarks for computer use agents, moving closer to human-level performance on complex tasks. Instead of relying solely on predefined rules or scripted flows, it uses intelligent planning and grounding to take meaningful actions in unfamiliar interface contexts. That ability to bridge the gap between this was trained for this exact setup and this is a new interface but still workable is rare. In addition, the framework supports multimodal interaction, visual perception plus textual reasoning plus action decision. It understands screenshots and GUI state, reasons about what needs to be done, and then executes the right sequence of actions. This level of autonomy combined with visual awareness is what makes it feel like a genuine agent rather than just a macro or one-trick tool. Finally, Agent S is open source and designed for extension. It gives developers a platform to build customized agents that can automate complex workflows, integrate with new tools, and evolve over time. For anyone working in automation, productivity, or human-computer interaction research, it offers a powerful base to push the boundaries of what an agent can do in real-world settings. Project number 8, Chronos, unlocking future patterns with cutting-edge AI. What really makes this tool stand out is how it treats time series forecasting, not as a niche data task, but as a foundational modeling challenge, and tackles it with the same scale and ambition as large language models. Instead of building models from scratch for every new dataset, it offers pre-trained models that can instantly be adapted for univariate, multivariate, and covariate-driven forecasting tasks, meaning you can plug historical data and optional influencing features and get ready to use predictions. Another differentiator is its architecture. It uses ideas from transformer and language modeling worlds to tokenize and sequence encode time series, treating a sequence of values like a language of its own, and thus leveraging the immense advances from foundation models to forecast future sequences. That shift in mindset gives it a huge strength: generalization. The tool also excels in performance and efficiency. In its Bolt variant, it introduces a patch-based design that chunks and encodes time series segments very intelligently, leading to significant gains in speed and memory efficiency without sacrificing accuracy. The results show this isn't just clever marketing. The tool delivers state-of-the-art zero-shot capability on multiple benchmarks. Beyond raw performance, the key uniqueness lies in its practical job readiness. It handles complex real-world forecasting problems, multiple time series, external covariates, probabilistic forecasts. With the same toolkit, you don't need to rebuild a new model every time your data shifts context. That lowers technical friction and opens forecasting to a broader audience. Finally, the fact that it is open source, backed by major research from Amazon Science, and structured for production usage, makes it far more than a demonstration toy. It brings together research-grade modeling and production-grade deployment. That union is rare, and is exactly what gives this tool its unique edge in the world of forecasting. Project number 9, Servo, reimagining web rendering with Rust and parallelism. Servo is a remarkable open-source engine that truly changes the game when it comes to how web content is built and rendered. What makes it unique is its focus on parallelism, safety, and performance, all packaged together in one bold project. Instead of sticking with the traditional sequential rendering model, Servo is designed from the ground up in Rust to harness multiple CPU cores and modern hardware architectures. That means it doesn't just render a web page, it breaks down a page into components and actively works across threads, reducing bottlenecks and improving responsiveness. Another standout detail is how Servo prioritizes memory safety and correctness. Rust brings ownership and borrowing rules that prevent whole classes of bugs common in browser engines, like use after free or data races. By leveraging that, the engine builds a safer foundation for web platforms. It also means developers embedding web technologies can rely on fewer surprises and more predictable behavior. Servo's architecture embraces modularity. The project isolates parts like layout, styling, rendering, and compositing, enabling better experimentation and evolution. Because of that, it's not locked into one legacy stack. Instead, it opens doors for new approaches, such as GPU-accelerated rendering, web GPU support, and tighter integration between web content and host applications. This flexibility makes it compelling for applications beyond a standard browser, anything that needs embedded web UIs or innovative web features. Finally, the global collaboration and commitment to open web standards make the project stand out. It isn't just about one company's product. Servo brings together a vibrant community of contributors and a vision to push what the web engine can be. In short, it's not merely another browser core, it's a fresh vision for the web at high performance, built with modern tools, designed for parallel hardware, and engineered for a future where web content is smarter and stronger. Project number 10, SeaweedFS. Fast, scalable, and simple blob object file storage. What sets SeaweedFS apart is its remarkable ability to handle massive scale, billions of files while maintaining extremely low overhead and high performance. Rather than relying on a heavy central metadata server that becomes a bottleneck, it uses a clever design where the central master only tracks data volumes, letting volume servers manage most of the file metadata locally. That means for typical file reads you get O1 disk seek, just one read to fetch the file data, and minimal metadata overhead per file. On top of that, SeaweedFS shines in its flexibility and simplicity. You can scale by simply adding more volume servers without painful data rebalancing. It supports tiered storage, hot, warm, cold data, by keeping active data locally and offloading less frequently accessed data to the cloud, yet still maintaining fast access. And it's built with multiple protocols in mind: Object Store, S3 API, traditional file system mount, POSIX fuse mount, cloud tiering, erasure coding, replication across data centers, even integration with Hadoop or Spark. Another standout is its operational simplicity for huge workloads. The entire architecture has been engineered to avoid single points of failure and to minimize complexity. When you add a volume server, the system doesn't need to reshuffle all your data right away, it just grows. Because of this, it works well for use cases with tons of small files, which many systems struggle with. Finally, SeaweedFS supports enterprise-grade features, encryption, erasure coding for cost-efficient durability, cross-data center replication, cloud drive mounting, WebDAV support, and a wide range of metadata store options. All this makes SeaweedFS not just another distributed file system, but a genuinely unique offering for modern data storage demands, combining speed, scalability, and simplicity in one package. That's a wrap on our second deep dive. We've covered everything from optimizing existing AI agents with Agent Lightning's centralized learning store and building customized robotic workflows with the 3D printable SOARM100 and more. Which project will you be implementing first? Let me know below. Like, subscribe, and I'll see you in the next video.